You've seen it a million times, right? A bird perched on a power line, just hanging out. It's so common we don't even think about it. But if you do stop and think, it raises a pretty fascinating question. So today, let's finally unravel this mystery that's literally hiding in plain sight right above all of our heads.
All right, so let's get right to it. We've all seen that tiny little sparrow sitting on a wire that's carrying thousands of volts, and it's completely unfazed. How in the world is that possible? Well, the answer, believe it or not, starts with some beautifully simple physics.
Okay, to really get our heads around this, we have to start with the fundamental rules that keep these little guys safe. It all comes down to how electricity actually behaves.
So it all starts with this thing called voltage difference. The easiest way to think about it is like water pressure. Water only flows if there's a difference, right? Like from a high-pressure pipe to a low-pressure faucet. Well, electricity is basically the same. It needs that push, that difference to get it to move from a high-voltage spot to a low-voltage spot. And this right here is the absolute key. When a bird is just chilling on one single wire, both of its feet are at the exact same super high voltage. There's no difference in electrical pressure from one foot to the other. So the electricity has zero reason to take a detour and flow through the bird's body.
You see, for electricity to actually move and do anything, it has to complete a circuit. It's always looking for a path to a place with lower voltage, and most of the time, that's the ground beneath our feet. A bird on a single wire, it just isn't offering that path. For the electricity, it's a dead end.
Another way to think about it is that electricity is kind of lazy. It always takes the path of least resistance. That copper power line is like a massive, wide-open superhighway. A bird's body, by comparison, is like a bumpy, unpaved side road. So that massive current just keeps humming along that superhighway, pretty much ignoring the bird entirely.
So there you have it. The simple answer is, as long as a small bird keeps its feet on that one wire, the laws of physics are its best friend. It's perfectly safe. But that's not the whole story. Not by a long shot. Because that simple, almost reassuring physics lesson, well, it masks a huge and mostly invisible conservation crisis that's unfolding on our power grid every single day.
This number, it's just staggering. Some estimates suggest that as many as 5 million birds die on power lines every single year in certain parts of the world. This isn't just a few accidents here and there. This is a massive, global threat to a lot of different species. And this is the question that changes everything, right? If sitting on a wire is so safe, what on earth is going wrong? Well, the answer has less to do with the tiny sparrows and more to do with the really big birds and the way we've designed the poles they try to land on.
Electrocution happens when a bird accidentally gives the electricity that path it's looking for. It usually happens in two ways. First is phase to ground. That's when a bird touches a live wire and a grounded part of the pole, like a metal arm, at the same time. The other is phase to phase, touching two separate wires at once. In either case, the bird's body suddenly becomes the bridge that completes the circuit.
And this is why large birds like eagles, hawks, and owls are so incredibly vulnerable. A tiny bird's wingspan isn't wide enough to bridge that gap. But a big raptor, with a wingspan that can easily be 4, 5, even 6 feet across, it can easily touch two dangerous points at the same time, just by landing or taking off. In a heartbreaking twist, its magnificent size becomes its greatest liability.
This problem wasn't born overnight. Nope, it actually grew up right alongside our electrical grid. A really tragic, unintended consequence of building and powering our modern world.
The first hints started way back in the 1870s with the new telegraph wires, but that was mostly collisions. As the voltages got higher, the danger got much, much worse. The first official reports of eagle electrocutions showed up in the 1920s, but it wasn't until the 1970s, when investigations into widespread eagle deaths out west revealed the shocking scale of the problem, that people really started to pay attention. And that's what led to the creation of APLIC, a super important team-up between utility companies and wildlife experts to finally figure out some solutions.
And the good news is, for the last few decades, engineers and biologists have been working together on this, and they've come up with some incredibly effective, common-sense solutions to make our power grid a whole lot safer for birds.
A lot of the solutions really just come down to smarter design. When you're building new power poles, it's pretty simple. Just build them with more space between the dangerous parts, so a big bird can perch safely. For the millions of poles already out there, it's all about retrofitting them, covering the hot spots with insulation or installing little plastic spikes that gently discourage birds from landing in the most dangerous places. Oh, and they also add markers to make the lines easier to see, which helps prevent collisions too.
But the challenge is evolving.
As our world changes, our need for electricity is exploding, and that means we need even smarter solutions. We're now entering this really exciting era where cutting-edge technology is completely revolutionizing how we protect birds.
I mean, think about this for a second. The massive boom in AI is creating data centers that are incredibly power-hungry. A single one can use as much electricity as 100,000 homes. That's insane. Suddenly, preventing a power outage caused by a bird isn't just a conservation issue. It's a critical economic necessity.
And the toolkit we have today is straight out of science fiction. We're talking about autonomous sensors that can see a large bird approaching and use a targeted pulse of sound or light to gently warn it away. We have AI that can analyze the grid and predict the highest risk areas before an accident happens. We even have drones that can fly up and safely install all this protective gear without ever having to shut the power off. It's a proactive, high-tech approach to a problem that's over a century old.
And if you want proof that this stuff works, just get this. Many birds can see ultraviolet light, which is totally invisible to us. So, by lighting up power lines with a special UV light at night, we can make them glow for birds, without creating any light pollution for people. A study on sandhill cranes found this one simple trick reduced collisions by an almost unbelievable 98%. 98? That's a game changer.
So, we started with a really simple physics question, and we've ended up with a really complex challenge that's right at the heart of our tech-heavy future. As our demand for power grows and grows, so does the pressure on wildlife. The real question now is, can we innovate fast enough? Can we build a grid that's not just powerful enough for AI, but also smart enough and safe enough for the incredible wildlife that shares our world?
Don't forget to like and subscribe for more How Meets History.